Hello guys, welcome back to my channel, Taking Boy. In this episode, I will be talking about column tuning. As you know, the column either it is absorber, distillation column, reflux absorber, or anything about a column is one of the most trickiest, probably the hardest as well, model to be solved. Yeah, in the process simulation software. Yeah, in terms of the convergence here, because in this column operation we need iteration to comply to the mass and heat balance and equilibrium balance also. So it is one of the quite trickiest among the others. So before we learn about how to troubleshoot when we have convergence error, but now in this episode I will cover about how if our column is able to converge but the result is not we are expected, not as what we are expected. So in this video I will having this example. I will use acid gas removal section, because here we have two kinds of column. The first one is absorber, where the CO2 will be absorbed by amines. In this case is DEA. And the second column is the regenerator, where the rich amine will be regenerated, so the CO2 could be separated from the amine, and the amine can be circulated back. So this is a quite interesting process, and I think that when we do tuning, we can do here in these two column. Okay, so I will share my UniSim design file. So what is the problem here is right now my flow sheet is able to converge. The column is converged now. You see here, but the problem is my result is different from what the plan data. So here in the absorber, the sweet gas CO2 volume data from the plant is 0.39%. However, my result is 0.12%. So it is quite different. And the second one, the lean CO2 loading data from the plant is 0.018, but right now I get about around 0.0006. So you can see here that both column results in a different result. Yeah. From the original plan data. So what I want to do now is to tune this column operation so it will match the column data. So when you do tuning, actually, you need to change some parameters, and don't be afraid to change it, because sometimes for example, when you change the temperature a bit or the pressure a bit, it is okay, because the readings of the transmitter of the TIPI, you still have some margin to change that. Yeah, uh, as long as it is not too far. So in order to make this parameters to be matched with the plan data, I think it is still okay to change those parameters. But right now, I will try which parameters is the best to be tuned for this case. Okay, so first of all, I will do the tuning separately between these columns. So I will remove the connections first. Okay, I will remove that. For this one, I will create a copy. Copy from region fit. Then I will change this. Okay, that way. So I have isolated these two columns from the system and the recycle streams too. So we are good to go. Okay, first let's start with the absorber here. Um, so right now we will see that our absorber is better than what it is should be because the CO2 volume fraction is smaller in the sweet gas if we compare it to the plant data. So we need to think now how to make this column operates uh, in a bad way. Yeah. So the CO2 volumetric content would raise up. Okay, because right now it is better than the plant data. So first, we could try to manipulate the temperature of this DEA. So let's see how if I increase uh, the temperature by a bit. Okay, for example, I will increase to 36, and then how about the gas contraction? Yeah, I will increase this by 36. Okay, so you could see that 1 degree Celsius change not really affecting the CO2 volumetric content. So it will be affected when the change is very big, for example, like 45 maybe. Yeah, you could see that the volume fraction is changed now, become 0.09. If I get back to 25, yeah. So when I change the temperature, we could see that 1 degree change is not a good one. Yeah. So we could we could have a conclusion that maybe we can try another parameters. For example, the volumetric flow rate of the DEA. So logically, if we have more amines, we will absorb more. So when we decrease the amine, we will have a bigger CO2 volumetric content in the spit gas. So let's try to decrease this by maybe to 40. Yeah, you could see that when we decrease about 3 meter cubic per hours, uh, the CO2 volumetric content is increased into 0.17 from 0.12. But however, it is still not enough because the plant data is 0.39. Yeah. So we should think again what probably the correct parameters to make this happen. So one of the parameters that mostly not not being recognized is the efficiencies. Yeah, the efficiencies of the components. So you could see here right now, my efficiencies value is calculated from the sizing data. So right now the value is around 0.15 until 0.2. If I change this CO2 efficiencies value, we could able to tune how effective is the absorber column or the column. Okay, so how to change this one? Yeah, since this one is a calculated value, is by clicking this reset H to S CO2. You could see previous one is in the black color, which we cannot change, but now it is in red color, and now we can spec if we want to have the same value for each stage. Uh, we have this efficiency multispec, so you could write maybe around 0.14. and then you click specify here. Okay, and then click run. Yeah, you could see that right now the CO2 volumetric content increased into 0.23. So we can decrease further. For example, 0.3. Okay, little bit more. Okay, almost there. So maybe around 0.117. Okay, almost there. 0.115. Oh, I haven't specified right now. Yeah. Okay, so in when our CO2 efficiency is around 11.5%, we could get the same result, yeah, the same CO2 volumetric content result with the plant. And by this simulation, actually, we also can conclude that if the efficiencies is calculated from the sizing of the tray, or the other words is if our column is in a good condition, it able to operate to make the CO2 volumetric content into 0.12. But right now, the condition is 0.39 CO2. So you could say that there's a problem here in the column because basically when you're having this column in a good way, you can get a better CO2 volumetric content in the split gas. But now it is higher. So previously the efficiency is around 0.16 up to 0.202, but now the efficiencies of the packing it is around 11.5%. So it is one of the way to evaluate uh, the column, yeah, whether the packing is still good or not, whether if there is any problem here, when you change the CO2 efficiency value, it will affect how much CO2 it is available in the sweet gas. Okay, next I will move here. We could see that the lean CO2 loading data from the plant is 0.018. Right now, the lean CO2 loading value is around 0.0006. So it is the same here that we have a better value in the simulation. Yeah, if we compare it to the plant data. So if you don't know yet about the loading is a ratio. Yeah, you can see here the equations. Lean CO2 loading means that uh, we will divide the lean CO2 flow. Yeah, so CO2 flow in the lean uh lean amine. Yeah, lean amine divided by the amine molar flow rate. Okay, so if we have more CO2 in the lean amine, it implies to a better. Oh, sorry, it is not a better column operation. Yeah, because the regeneration will be not too good. Yeah, will not operate too good. So the CO2 we will have some CO2 in the lean amine stream, yeah, which is not a good one. So when your lean CO2 loading is higher, it means that your uh, column operates worse than the original plan data. Okay, so you could try some parameters. Actually, the first one is when we change the regen fit copy to the regen fit that is connected to the absorber, because you could see here that in the regen fit, the CO2 content is smaller. Yeah, we need to replace first with the original, because the CO2 content is different now. Since the sweet gas CO2 content is higher, so the rich DA CO2 content, yeah, or the rich loading will be lower. Yeah, because the CO2 is larger here. Okay, so I will run. So if the rich loading is lower, we could expect that we will have also a lower regen bottoms. But here we could see, because of the CO2 content is not that pretty much changing, the lean CO2 loading is still the same. But wait, oh, that is because I connect this with this DA2 contactor. So I will change the import, edit import. I will change it to DA2 recycle. Yeah. So right now, I think it is quite different, but still, it is too small if we compare to the plant data. Okay, so we could try several things. The first is by changing the specs here. For example, you want hotter regen. You could see what is the effect. Right now is 6E minus 3. How about if 55? Yeah, you could see that the cheese is not that significant. Yeah. How about the duty? If we change it 1.4E7, you could see that the value is smaller now, but still it is not that significant because we have decreased the duty by 1E7, so it is a very drastic change in operation. 1E7. Yeah, previously is this one. Sorry, what's the previous one? Okay, I think this yeah, it's around 6, yeah, 6E minus 3. So again, we can change the efficiency value. Okay, you could see that the efficiency value is quite variative now. The the large part is at the bottom column. It is around 0.3. So we can try to change this. I will have the same value for every stage. For example, around 0.2. Okay, so if we spec at 0.2, it is lower. So I will try 0.15. Okay, so right now it is 0.013. It is quite close. So we need to have a larger CO2. It means that maybe it is around 0.148. Okay, not that significant. 0.146. 0.013. 143. Okay, 0. Okay, how about 0.14? Okay, so 0.018. So half. Yeah, almost there. Okay, so quite close right now. So you could see that right now the efficiency value of both columns, yeah, for the CO2 is about 11%. Yeah, quite the same. It's here. Yeah, 11%. So yeah, with this kind of settings, we are able to meet the plant data. Yeah. Uh, the loadings and also the CO2 concentration in the sweat gas is quite close now. And the remaining work is to get back this recycle. Yeah. Okay, you could see that the value is not that different before we connect the recycle stream. So yeah, the tuning is done. So this is it. I have give you an example of how to tune column operation. One of the most effective way actually is to set or to tune the efficiencies, because a small change in the efficiency would impact the concentration of the outlet quite significantly. Uh, so that's it. Thank you for watching. Don't forget to like and subscribe, and see you in the next episode.